Hello, everyone. My name is César Garza. I'm a math professor in the Department of Mathematics and Statistics, and I'm going to show you how I do my active learning classes so that hopefully after watching this video, you also participate in an active learning class next semester. So in this presentation, I'm going to show you my method of teaching with active learning. I like to call this method rewards for all. We're going to go over the traditional lecturing styles, how this is not effective, the scientific evidence about active learning, and how it is demonstrated that this is the best method to teach STEM courses. Then I'm going to show you some alternatives to the traditional lecture style. Then I'm going to introduce more details about active learning style that I use, the rewards for all method, if this works, my experience after 5 years of teaching with this method, and some of the challenges and future discussion about this method. So let me talk about the old IU approach. For centuries, we have honored an IU teaching paradigm. So what this means is that instructors provide the first contact with the material just by lecture. Then students are expected to solve exercises outside of class. I lecture, then you do the homework alone. However, learning, we know that is not a spectator sport. How many times we hear from students, I understand perfectly when you lecture, but then I can't solve any problems at home. Lecture only demonstrates that the teacher can do mathematics or coding or chemistry, but this rarely helps a student. So with what I want for my students is I want my students to be active in class and at home. I want them to engage in STEM activities instead of just playing computations. They should explore and find their own multiple ways to solve problems. And the students should be creative and they should be having fun in the classroom. I want my students to be experimenting, conjecturing, proving, and generalizing. We know that classroom time is precious. Do you want your students to spend classroom time on first contact with the new material or engage in higher learning activities? Let me show you about some of the studies about alternative teaching styles. In the last decade, the Calculus Concept Inventory, CCI, was designed as a successor to the Force Concept Inventory in physics. This is a test of the most basic conceptual comprehension of foundations of a subject and not of computational skill. The CCI results were that traditional instruction has remarkably little effect on basic conceptual understanding. Dramatic differences, up to 2 standard deviations in CCI gains between traditional teaching and interactive engagement instruction like active learning, has a much dramatic effect than the instructor, the class size, or even the student preparation. We have another study, Evaluation of the Inquiry-Based Learning Mathematics Project from 2011. They captured data for 100 sections, 3,200 students, and 4 universities. And IBL, also known as active learning, over 60% of class time spent giving and listening to student presentations, working in small groups, discussing ideas that generally arose from a group problem or student-presented solution. That's what we traditionally mean active learning or inquiry-based learning. And well, what we call non-IBL is when, over most of the time of the class is spent just listening to the instructor talk. IBL students earn grades in subsequent courses that were as good or better than the grades of their non-IBL peers. This is something that I can confirm from my own experience teaching IBL courses. Because work was due nearly every class, the workload was steady rather than test-driven. Non-IBL courses tended to reinforce prior achievement patterns, helping the rich to get richer. So the smart students are just doing better in non-IBL courses. In contrast, IBL courses seem to offer an extra boost to lower achieving students, especially among pre-service teachers. There is no evidence of harm done to the strongest students. Indeed, high-achieving students may be encouraged by an IBL experience to take more mathematics courses, especially more IBL courses. The students in my Introduction to Proof classes, they actually stick with me for advanced classes because they appreciated the active learning style, and that really helped in other classes. What are some alternatives to lecture? Maybe you already heard about flipped classroom or inverted classroom. This is when the professor leaves a video lecture and then in the classroom time, the working groups through worksheets or other related activities. But still may be passive. If you only leave a video recorded, the students are still sitting at home watching passively at a lecture. Some students are still going to see the first contact of the material in the classroom. What we propose is to eliminate the traditional lecture, replace with active student preparation for class. So we try to adapt this to I, we, you approach. We teach as we were taught, but I mean, if we are instructors, we were not typical. We were largely self-taught, okay? Both instructors and students are extremely comfortable with lecture. That's one of the problems with traditional teaching. It's very hard to break the cycle. How could I cover the material in the syllabus if I don't lecture? So you may feel trapped. You may feel like with active learning, you're not going to cover everything you want to cover in the classroom. But we're going to see that that's actually not true. We all know that it takes effort to change. There's more work the first time you teach an IBL course. So what I'm going to show you, my active learning style, is an adaptation of Professor David Pengelly's style. He developed this method for 20 years of evolution and polishing. I also adapted this style to UHC and my students in mathematics courses. I'm pretty sure that you can also do your own adaptations for other STEM courses. So I was in close communication with Professor Pengelly, and I was able to adapt this to my UHD classroom. I have experience with IBL courses in college algebra, calculus 1, calculus 2, probability and statistics, analysis, modern algebra, introduction to proofs, just to mention some courses. So the goal with active learning is I want my students to read ahead of the class, and they should also think about what they read. So they should write some responses to the material they read. So students must do preparatory work before class. In the classroom, students work in groups or individually. Sometimes they do presentations, sometimes they just work in problems. So that's more preparation about the material. After the class, there is post-class harder homework at a higher level. Sometimes it's going to be like coding. Sometimes it's going to be more advanced problems in mathematics. So this is to reinforce the material they're learning. So we pass from I, we, you method to you, we, you. What do I mean by the layer? Well, so it means that you are going to read, that means the student. You are going to prepare the questions and the questions to the professor and the answers to the reading questions before class. Then in class, we are going to review the material. We are going to answer any questions you may still have. And then you and your classmates are going to work with some extra problems or coding challenges. And then you're going to take some work after class. To make reading assignments more manageable, I summarize entire sections in the textbook to, let's say, 5 to 7 pages with fully solved examples. So this is the kind of lecture notes I prepare for my class. This is completely optional, okay? You don't have to go through this. I decided to summarize some sections of the textbook because students usually don't want to read 10, 15, 20 pages from a textbook. It's very dense. So I like to summarize this content into 5 or 6 pages with lots of graphs, diagrams, examples. The important information is clearly enclosed in color boxes and things like that. So my students have to read just this part. I use online tools like everyone here. I use Blackboard or Canvas to have all my homeworks, all my activities completely organized in an online tool. All the lecture notes to read are also in Blackboard or Canvas. Everything is going to be managed through these learning platforms. The homeworks can be submitted online if a student, especially the A homeworks, the reading assignments that students have to complete before classroom time, that has to be submitted online, and the work they do after class, okay? Or if a student is not able to go to a classroom, well, students can still submit this online. For courses aimed at computer science or data science or math majors together, I like to incorporate software like Julia, programming tools like Julia, Python, or R to give my students some added value to the class. Okay, so in my classes, the active learning style is we have something that I like to call the ABC rolling trios of assignments. So what that means is that the A homeworks, this is the material they have to read before class. They have to write responses to my questions, and they have to write their own questions to the professor so that we can give a more meaningful lecture the next time. I read and grade all these answers, but only based on completion. Students receive full points if they answer all the parts thoroughly, even if the answers are incorrect. And I use these answers and questions to me to prepare the next lecture. The B homework is the work they do during classroom time. These are just some warm-up problems. So what we do in class is we briefly discuss the reading responses to the A homework. We can go quickly over some examples just to teach my students how to solve these problems. I don't lecture during class, meaning that I don't go over the concepts or the definitions because students already read about them. I prefer to focus more on examples and applications during the class. After we complete the B homework in class, and I just give a quick grade for the B homework based on how much students complete in the classroom. After that, we have the C homework. This is a post-class assignment, very few harder problems, or sometimes application problems in R or Julia, and these are carefully graded from 0 to 10. This is where I see if students are really understanding the material. So I want to show you how students answer these reading assignments. So you get to see how creative they can get or what kind of feedback you can receive with active learning. This is an example of an A homework in my class for probability and statistic. I want to show you the problems that I assigned about this. So for example, this was a homework that was due on Monday, August 28th. The students had to read my lecture notes on section 2.3. And then I always give them 2 questions, but these are not going to be questions that they can answer yes or no. These are also questions that they cannot answer with a simple number. They have to tell me what they think. They have to justify the answer. So for example, this student read the problem and he understood that this kind of problem sampling without replacement and on order, and he gave me the answer. Of course here, I'm not expecting everyone to get all the answers right. But he also answered the second question. It was about what they read in this example from my lecture notes. And after they read the example, I changed the problem a little bit. So then they have to try the example again, this time with new data, to see if they're able to do problems on their own before coming to class. But what I like most about the A homeworks is the feedback you receive in the last two parts. You see, after they answer some math questions, they write down here their own explicit questions about what they read, so that I take note of this, and then I can go over this when I lecture, or when I do my my so-called lecture next time. So for example, this student wants to know the derivation of permutation and combination formula, so I can spend more time on that. And finally, they give a reflection about how the semester is going for them, and if there's a topic that they like or they didn't like, if we're going too fast with the material or too slow. So this student is mentioning that the lecture notes are really helpful and they make the class lecture easy to understand. Okay, so you'll be surprised the feedback that you can receive here. You are engaging the students in a higher learning type of activity with this. So we have an A homework like this for every class. So if I teach Tuesdays and Thursdays, we have an A homework like this Mondays and Wednesdays before they come to class. And we also have B homeworks. These are fully work in groups during classroom time with the help of the professor. And we also have C homeworks given. In this particular example, this is going to be application projects done in R, because this is probability and statistics. And it's very important that students get some exposure with the R programming language for this class. This is something that they submit once every week. For other classes, we just have problems of mathematics. You can do coding exercises, you can do chemistry exercises or labs, whatever you prefer for the C homework. That's up to you. So an example of a B homework is something like this. So I have two problems for my class, and what I like to have, some of my students, I encourage my students to get some work done before they even come to class. Most of them do the work before coming to class. I'm actually very surprised to see a lot of students actually having all the answers correct as soon as we start doing the work. Okay, that shows dedication and that shows real commitment to the class. But anyway, students have about 30-35 minutes to do these problems. They work in groups. Of course, sometimes they're going to have some false starts. So this is where, as an instructor, you give them a nudge or you point to the mistakes they have so they can easily fix this. And by the end of the lecture, everyone finishes the problems and they can leave the class with the satisfaction that they actually understood more the material through practicing. Very often with the B homework, when I go to each desk, students tell me things like, okay, I'm very proud of myself because I did this problem by myself. Okay, so these are the kind of rewards students receive through active learning. As for C homeworks, for probability and statistics, they do these projects every week. Applications of probability for the R software environment. So they have these applications, and all the answers have to be done in R using R comments. Of course, I always give them video tutorials about R, so they know what to do for each project. Let me show you basically the schedule we follow with active learning. We have rolling trios like this. So for example, every Tuesday and every Thursday, we have a B homework, as you can see in this Gantt chart. Every week we have a C homework, so that's the long bar you see there. So C2 will be due Friday, and the next C homework is going to be due next week, so students know what's next. And as you can see here, to go to the B homework, students must submit an A homework before that. So we follow this schedule every week. Okay, the dynamics of the classroom are very simple. I reserve the first 30 or 40 minutes of the class to present additional examples. I also like to address the students' questions from the A assignments. The rest of the classroom time is reserved to work on the B assignment problems. I do not give explicit solutions, okay? I do not say, look, you have to obtain, I don't know, x equals 10. What I always tell, like, okay, you have to fix this part because look at the definition or look at what we did in this example. So students quickly correct the mistakes during the classroom. And as a reward, students can leave early if they finish all parts ahead of time. I mean, that way, even the super smart students that bring the answers before the classroom time, they have their own reward. Okay, they can leave early if they want, and everyone has a reward with this method. The A and the C assignments can be submitted online too. Okay, so I know what you may be thinking right now. With so much time dedicated to in-class activities, how am I supposed to cover all the material in the syllabus? You may think that you're losing time with the B homeworks in class, but actually, your organization of the class is going to be easier this way. With the ABC organization, you can actually cover more sections because before even the semester starts, you know what section you're going to cover each day. And students are going to be responsible to read the sections on their own. So even if you didn't cover one or two concepts from the section, students already read about that, so you can just focus on examples or some common mistakes about your topic. Okay? You can set up your own pace every day. That's what I really like about active learning. You do not depend on what's going to happen every day. The students are responsible for reading all the material, so you can focus on the parts that need to be re-explained or illustrated in more depth. What is my grading scheme here? Well, how do we make students to actually read on their own? Well, the reading part and the reading assignments should be a big part of your grading scheme. The AB assignments typically are worth in my classes from 21 to 25% of the final grade, with more weight put in the C assignments. Usually my C assignments are usually 13% of the final grade. I still have 3 midterms or 3 exams. They usually weight 39 to 45% of the final grade. You can assign less weight if you prefer. That's completely up to you, and put more weight on the ABC homeworks. In some classes, I have traditional homeworks in platforms like WebAssign or MyLabMath. You can put up to 10% of the final grade for these traditional homeworks. And in some classes, we have departmental final exam. Some other classes, you create your own final exam. Usually, I put 30% of the weight for the final exam. What do we get with this method? What are the rewards for the instructor and for the students? As a professor, the rewards you get are higher quality interaction with students. That's a more rewarding class for everyone. Okay, so what I mean by this, by higher quality interactions, is because this is not going to be the first exposure to the material for the students. During classroom time, you get much better questions. Students are more direct. Students know exactly the material they're not understanding. And they're going to ask you much better questions, and they're going to feel more satisfied with the class in general. Sometimes, for example, you can decide to do only 2 final exams instead of 3 only 2 partial exams instead of 3. So you may have fewer exams to grade if you decide. Okay, for some classes like college algebra, I have to stick with 3 exams and a final because we have a departmental final exam. But you can choose to do final less exams if you want. There's more rewarding homework marking because students are reading on their own. They're more independent. I do not spend more time with this overall. Once you design your active learning class, it's very easy to just move on to the next semester with the materials you already have. The syllabus feels less rushed. As I mentioned before, you can cover more material. You don't have to, put everything in just 5 minutes before the class ends because students already read about that, so you feel more comfortable teaching the material. You reduce the cram, exam, forget cycle. And the workload is more even. Students are doing more work every week, so you avoid burnout for the students. And of course, the student responses are way more rewarding. I'm going to show you some of the other responses that I received. I already showed you an example of an A homework. The question here is this actually working? Will students really read and write in preparation for class? Well, from my experience, I can tell you that most of them are going to do this. We want to avoid the lecture textbook trap. What do I mean by this? The trap is that we feel that students are not going to read what we assign, so we feel trapped and we try to lecture more during the class time, and then we're just repeating this vicious cycle. Then students are going to read less and less, and we're going to lecture more and more. So to avoid the trap, you have to make the students read, okay? And the students will read and write, even in basic classes, even in core classes like college algebra, if you assign weight to this for the final grade, okay? It has to count for the final grade so that students read. Also, you have to avoid explaining everything during class so that students feel more motivated to read on their own. Okay, they see the value and they become more enthusiastic about it. It may take a few weeks, but students usually get into the pace of active learning. The motto is that never do traditional lecture on material that students already can read. Will students prepare warm-up more problems before class? Well, yes. They see this as part of the grade. They see this as pressure from the instructor and pressure from the classmates. If they have to do presentations, well, they also have to prepare something so that they don't fail the other students. So they have to see the value in this. The ABC parts must be a very large part of the course grade, more than 21%. So there has to be a harmony between learning and evaluation. Okay, so what are the results that I see with active learning? Well, these are some of the examples of feedback and answers that I received in A homeworks. And let me tell you that this is just from college algebra, a very basic class. Students are not from STEM typically, but still, even in that class, I received questions like, how can we represent graphically a contradiction or an identity? This was for a college algebra class, a non-STEM student asking this. How can we find local or absolute extrema without a graph? So students were getting close to calculus way of thinking in college algebra with the A homeworks. And also very often I see answers like this. Professor, I had to watch YouTube videos, I had to watch tutorials from Khan Academy or other platforms in order to answer these questions in the A homework. That's actually the intention of the A homeworks. Students are really going for external resources to find answers. That's a big gain with active learning. These kind of reflections are impossible to get in a traditional lecture with zero prior exposure to the material. Now, in terms of grades, the one class that I can compare traditional versus active learning styles that I taught both methods is college algebra. Before the pandemic, I was able to compare two college algebra classes that I taught, one with traditional style, the other one with active learning style, and I can tell you that with active learning style, I got much better final exam grades. Now, for other classes, the improvement in the grades may not be as dramatic as with traditional teaching styles, but there are other rewards that you can see as instructor that may not be measured with grades. For example, what I can tell you is that when I taught Modern Algebra 1, which is a very tough class, where students actually have to write mathematical proofs, the 3 best scores at the beginning of my class came from students in the class before that were with me in active learning, Introduction to Proofs. The rest of the class was not with me. They were with a traditional teaching style method, and they really struggled the first month. They were not independent. They were not reading on their own. They were not able to be self-motivated. But as they adapted to active learning, I was very happy to see that all of my students quickly caught up to the advanced students in active learning, and they got very good grades overall at the end of the semester. I actually received a card from all the students thanking me for the work in that class. So this is something that you don't see in like evaluations or final exam grades, but you get to see a lot of student satisfaction with this method. Students feel more satisfied with their progress, and they see the benefit of their efforts immediately, and their progress is not dictated by one test. So another thing that I see in this method is that students are more likely to recover from a bad grade if they put all the work. I see very often students passing from a 40 or 30 in the first test to 60s or even 70s after they get used to active learning and they put the work. I have a student that took 3 classes with me with active learning, and the first time he only got a C with active learning, but the second and third classes, he was just getting A's. He really improved his proof writing skills with active learning, and he said at the end, you know, professor, this really works. We may not see it the first month or the second month, but the benefits are, for the long term, are really there. What are some of the challenges that I see here? Well, in UHD, we know that students in my classes have to deal with full-time jobs, family issues, long driving times, so attendance can be a challenge. Some of them turn in the assignments in Blackboard when they miss a class, so this is something that I allow them to do as long as they do that before the due dates. About online classes, I was able to adapt this active learning style to synchronous online classes during the pandemic. I used Google Docs that anyone can edit instead of traditional B-homeworks. So we did live Zoom sessions to solve problems through WebAssign or MyLabMat. But it's still a challenge to adapt this to online asynchronous courses. You don't have the students with you when you record the lecture. So I cannot adapt this yet to online asynchronous courses. That's a main challenge right now. You have to give them also a calendar of assignments at the beginning of the semester so that students keep track of all the activities and their due dates. It's very easy for students to get lost with all the activities and all the due dates. But I think this method is very easy to adapt to other STEM courses, not just math. This is especially suited for upper division classes because students are more used to reading ahead of time. Students can be more motivated, but even freshman classes, it's not an obstacle to do this. I was very successful adapting this to college algebra or other lower level classes. Now, adapting active learning for summer courses can be quite a challenge because of all the rush in just 5 weeks. And another one of the main issues that I have is the students that register 1 or 2 weeks late, they cannot get into the rhythm of ABC assignments. So some of them do catch up at the end. Some of them, they just drop because they were not with you the first week or so to adapt to this. So you may talk with them one-on-one so that they get on track. Okay, so that is the way I run my classes. This is my active learning style. I really hope that you adapt this to your own classes next semester. I'm going to be there for you all the way for the next semester. I can help you with tutoring, preparing materials, watching your actual lectures. You can also come to my lectures to see this by yourself. So I really hope that you consider this. Thank you so much for watching the video.